Note: a 400 amp meter socket rated at 320 amps continuous load should not be used for a 380 amp service. The continuous load rating of a meter socket is the maximum amperage it can handle indefinitely without exceeding its safety limits. In this case, a 400 amp meter socket with a 320 amp continuous load rating can safely handle up to 320 amps of continuous current flow indefinitely. If the service requires a continuous load capacity of 380 amps, and this exceeds the continuous load rating of the 400 amp meter socket, therefore, the meter socket would not be able to handle the continuous current flow required by the 380 amp service. Using a meter socket with a continuous load rating lower than the service amperage can lead to several safety concerns. Firstly, overheating can occur, as the meter socket could overheat if it is subjected to a load that exceeds its continuous load rating. This can damage the meter socket and pose a fire hazard. Secondly, electrical failure can occur, as the meter socket could fail if it is subjected to a load that exceeds its continuous load rating. This could result in a power outage and potentially damage to electrical equipment. Thirdly, using a meter socket with a continuous load rating lower than the service amperage could void the manufacturer's warranty. If you decide to install a 380 amp service, you should also upgrade the meter socket to one rated for a continuous load of at least 380 amps. This will ensure that the electrical system is safe and reliable. Meter sockets are rated with two amperage values. One is the maximum amperage that can pass through the socket. The second value is the continuous amperage rating, which is the maximum current the socket can handle for 3 hours or more. National Electrical Code, Section 220.87 permits using the actual maximum demand to calculate the service size if the occupancy has been occupied for at least 1 year. This requires using an ammeter to measure the highest current flow during a 15-minute interval over a period of 1 year. The maximum demand should be adjusted during times when it is not at its typical occupancy level. If you cannot measure the actual load, you must calculate the total connected load according to Article 220 of the National Electrical Code. The first step in calculating the load is to determine the standard loads for lighting and receptacles, as outlined in Section 220.12. This is calculated in volt-amps per square foot depending on the type of occupancy. For a dwelling, the general lighting load is 3 volt-amps per square foot. For other occupancies, the volt-amps per square foot requirements can vary. The next step is to add in the small appliance branch circuits required in Section 220.11. For a dwelling, there must be a minimum of 2 20-amp small appliance circuits and 1 20-amp laundry circuit. These are calculated at 1500 volt-amps per circuit. Next, you must calculate the demand load for appliances. Fixed appliances are calculated at their nameplate rating. Ranges are calculated according to Table 220.55, and the load can vary based on the rating of the range. If the range is rated 12 kilowatts or less, the demand load is 8 kilowatts. For ranges larger than 12 kilowatts, the demand load is increased. Clothes dryers are calculated at 5000 volt-amps or nameplate rating, whichever is larger. Heating and air conditioning loads are calculated at 100% of the nameplate rating. Motors must be calculated based on their horsepower rating, as outlined in Tables 430.248 and 430.250. These tables provide the full load current based on the motor voltage and horsepower rating. Electric vehicle chargers are calculated at 100% of their rated load. After calculating the total connected load, demand factors can be applied as permitted in Article 220 of the National Electrical Code. For a dwelling, the first 3000 volt-amps of the general lighting load is calculated at 100%. The remaining general lighting load can be calculated at 35%. For other occupancies, demand factors vary depending on the type of occupancy. The service size must be adequate for the calculated load. Section 230.42 outlines the minimum size and rating for service entrance conductors. For a dwelling, a 100 amp service is the minimum size permitted. The service size must also be calculated to ensure the voltage drop is within acceptable limits. Voltage drop is the decrease in voltage that occurs as electricity flows through a conductor. National Electrical Code Section 210.19a on FPN number 4 recommends that the voltage drop on a branch circuit should not exceed 3%. The voltage drop on a feeder should not exceed 3%, and the total voltage drop on the feeder and branch circuit should not exceed 5%. Voltage drop is calculated using Ohm's law. The voltage drop is equal to the current multiplied by the impedance of the conductor. The impedance of the conductor is affected by the length, size, and material of the conductor. To minimize voltage drop, use larger conductors, shorter runs, and conductors with lower impedance. Inductors must be protected from overcurrent using fuses or circuit breakers. Overcurrent protection devices must be sized to protect the conductors from overheating and causing a fire. Section 240.4 outlines the requirements for overcurrent protection. The overcurrent protection device must be sized no larger than the ampacity of the conductor it protects. The ampacity of a conductor is the maximum current it can carry continuously without exceeding its temperature rating. The ampacity of conductors is listed in tables 310.16 and 310.17. These tables provide the ampacity of conductors based on the conductor size, insulation type, and installation conditions. When selecting a meter socket, it's crucial to consider not only the continuous load rating but also the short-circuit current rating, also known as the withstand rating. This rating indicates the maximum amount of fault current the meter socket can safely handle during a short-circuit event without failing catastrophically. If the available fault current at the meter socket exceeds its short-circuit current rating, it can lead to severe damage, including melting of components, arcing, and even explosions. The available fault current depends on factors such as the utility transformer size, impedance of the service conductors, and the distance from the transformer. Consult with the local utility company to determine the available fault current at the service entrance. Choose a meter socket with a short-circuit current rating that meets or exceeds the available fault current. Additionally, ensure that the meter socket is properly installed and grounded to provide a safe path for fault current. The meter socket enclosure must be bonded to the grounding electrode system to minimize the risk of electric shock. The grounding electrode system typically consists of a ground rod, ground plate, or the metal underground water pipe. The size of the grounding electrode conductor is determined by Table 250.66 based on the size of the service entrance conductors. The meter socket should be installed in a location that is readily accessible for inspection and maintenance. Ensure that there is adequate clearance around the meter socket to allow for safe working conditions. The meter socket should be protected from physical damage, such as being struck by vehicles or equipment. If the meter socket is installed outdoors, it should be weather resistant to protect it from rain, snow, and other environmental factors. Regularly inspect the meter socket for signs of damage or deterioration, such as cracks, corrosion, or loose connections. If any problems are found, they should be corrected immediately to prevent safety hazards. When working with electrical equipment, always follow safe work practices. Wear appropriate personal protective equipment such as safety glasses, gloves, and insulated tools. To energize the circuit before working on any electrical components, use a voltage tester to verify that the circuit is de-energized. If you are not qualified to perform electrical work, hire a licensed electrician. Electrical work can be dangerous, and it is important to take the necessary precautions to protect yourself and others. Local codes and regulations may have additional requirements for meter socket installations. Check with the local building department to ensure that the installation complies with all applicable codes. Some jurisdictions may require a permit for meter socket installations. The meter socket should be listed by a recognized testing laboratory, such as Underwriters Laboratories or Intertech. Listing ensures that the meter socket has been tested and meets safety standards. The meter socket should be installed according to the manufacturer's instructions. Failure to follow the manufacturer's instructions can void the warranty and create safety hazards. When selecting a meter socket, consider the environmental conditions in which it will be installed. If the meter socket will be exposed to corrosive substances such as salt spray, choose a meter socket that is made of corrosion-resistant materials. If the meter socket will be installed in an area with extreme temperatures, choose a meter socket that is rated for those temperatures. When replacing a meter socket, be sure to disconnect the power before removing the old meter socket. After installing the new meter socket, reconnect the power and verify that it is working properly. If you are not comfortable working with electrical equipment, hire a qualified electrician to replace the meter socket. Meter sockets are an essential part of the electrical system, and it is important to select and install them properly. By following these guidelines, you can ensure that the meter socket is safe and reliable. Always consult the National Electrical Code and local codes for specific requirements. Consider future expansion when sizing a meter socket. If there is a possibility that the electrical load will increase in the future, choose a meter socket that is large enough to accommodate the increased load. It is generally better to oversize a meter socket than to undersize it. When sizing a meter socket, consider the diversity factor of the electrical load. The diversity factor is the ratio of the maximum demand of the load to the sum of the individual loads. If the diversity factor is less than 1, the meter socket can be sized smaller than the sum of the individual loads. However, it is important to carefully consider the diversity factor to ensure that the meter socket is large enough to handle the maximum demand. Meter sockets are available in a variety of configurations, including single-phase and three-phase. Choose a meter socket that is compatible with the type of service. Meter sockets are also available with different types of terminals, such as screw terminals, stab terminals, and compression terminals. Choose a meter socket with terminals that are compatible with the type of conductors being used. When installing conductors in a meter socket, be sure to use the correct size and type of conductor. Use a torque wrench to tighten the terminals to the manufacturer's specifications. Over-tightening or under-tightening the terminals can cause problems. After installing a meter socket, perform a visual inspection to ensure that all connections are tight and that there are no exposed conductors. Use a multimeter to verify that the voltage and current are within acceptable limits. Meter sockets are typically made of metal or plastic. Metal meter sockets are more durable than plastic meter sockets, but they can also be more expensive. Plastic meter sockets are less expensive than metal meter sockets, but they are not as durable. The type of material to choose depends on the application. When selecting a meter socket, consider the reputation of the manufacturer. Choose a meter socket from a reputable manufacturer that has a proven track record of producing high-quality product. Read reviews of meter sockets before making a purchase. This can help you to get an idea of the quality and reliability of different meter sockets. When purchasing a meter socket, be sure to get a warranty. A warranty will protect you from defects in materials and workmanship. Meter sockets are an important part of the electrical system, and it is important to choose one that is safe, reliable, and appropriate for the application. Consider all of the factors discussed above when selecting a meter socket. Always follow the National Electrical Code and local codes when installing a meter socket. If you have any questions, consult with a qualified electrician.